Today we're doing the fifth set of notes about inverses, and this set of notes kind of stands alone. It doesn't necessarily go super well with this chapter, but this is a short chapter, so we decided to tack it in with this set of notes. So at the beginning of the notes, it has a review, and it says which of the following relations are functions. So the rule for looking at graphs is that a graph has to pass the vertical line test. If you're looking at a table, each x value can have only one y value. So when you're looking at this problem, letter A is not a function because the 4's repeat. Letter B is a function. Letter C would not be a function because if I draw a vertical line, it will be crossing twice. But letter D will only pass one time, which is a function. And right below that, it got cut off on my screenshot, but right up below it says to find the inverse of a relation on a table, switch X and Y. So make sure you add that onto your notes. So with that being said, I'm giving you a relation, and it's asking you to determine the inverse of this relation. So I'm going to take these two values and switch their spots in the table. So my first point is going to become 1, -1. My next point is going to become 2, 0, 3, 1, and 4, 1. And now it's asking you to graph these points. So I'm going to graph my first one in green. It's the original one. I have a point -1, 1. I have 0, 2, 1, 3, and 1, 4. So there is my original graph. Bear with me, it's a little difficult to graph on here. The next one is 1, -1, 2, 0, 3, 1, and a 4, 1. And my graph will look something to that effect. Letter C says, how is the line y equals x relate to the graph? So this is a great review on graphing linear equations. So technically this could be written as y equals 1x plus 0, which means my y-intercept is 0, and my slope is up 1 over 1. So I'm going to go up 1 over 1, up 1 over 1. I could go down 1, left 1, and so forth. So this is your y equals x line. And notice when you're looking at the inverse functions graphically, they are equal spacing around this line. It's like a mirror image on either side. So if you were to fold your graph in half along that diagonal dotted line, it looks the same on either side. And that's the relationship with inverses. On the next page, we're going to talk about how to find the inverse algebraically. So step 1 is going to be to switch x and y. And step 2 is going to be solve for y. Step 2 is your subjective step because there is no one clear-cut way in which you solve for y. It'll be different for every single problem. It just depends how the problem looks. The notation for the inverse you will typically see will look like this. So I know we did just spend a good amount of time going over negative exponents. This is not supposed to be a negative exponent. This is interpreted to be the inverse of f. So that's how you would pronounce it if you see that. So for our first example, they are saying that f of x equals 1/2 x plus 1. So I'm going to start this problem by saying y equals 1/2 x plus 1. Remember, f of x is a fancy old way of saying y. Now that I have that, I'm going to take my x and y and switch them. So this now says x equals 1/2 y plus 1. Notice I keep the format the same. To get y by itself, I'll subtract 1 from both sides. And now, if I need to get rid of this 1/2 in front of my y, I'm going to multiply both sides by the reciprocal. By doing that, this 2 over 1 and 1 over 2 is going to cancel, leaving me with y. On this other left-hand side, I'm going to take this 2 over 1 that I got and I'm going to distribute it in. 2 over 1 is really just 2, so I get 2x minus 2. So this is our inverse of f equation. Letter B, again, I'm going to start by writing y equals 2x plus 10. I'm going to switch x and y. I keep the format looking exactly the same. None of the numbers move. X and y are the only ones that move. And now I solve for y. So I will be subtracting 10 to get y by itself first. And now to get y by itself, I will be dividing by 2. There's a couple ways you could write this answer. You could leave it as a fraction, like so. You could go one step further and divide both of these values by 2. And when I do that, I get x over 2 minus 10 over 2. If you choose to go that route and split them up, you will have to simplify. So this means x over 2 minus 5. And just good conversation to have in case you were doing a multiple choice test. This is technically considered to be 1x over 2. So this could be rewritten as 1/2 x minus 5. In terms of acceptable answers, I would take this as an answer, I would take this one as an answer, or I would take the original one as an answer. This is the only one I would say I would mark maybe 1/2 point off because you could reduce 10 over 2. Our last one, letter C, again, we'll start by writing y equals 2/3 x minus 4. I'm going to switch my x and y, so I have x equals 2/3 y minus 4. And now we start solving for y. My first step will be to add 4. So I have x plus 4 equals 2 over 3y. And just like that first one, I'm going to go ahead and multiply both sides by the reciprocal of 3 over 2. That's going to cancel. So I am left with y on the right-hand side. And I'm going to take this fraction and distribute it in. So I get 3 over 2x plus, we multiply tops and bottoms, so 3 times 4 is 12 over 2. Just to kind of reduce my final answer, I get 3 over 2x and plus 6. So obviously 12 over 2 can reduce to be plus 6, and that is our final answer. So you have 3 practice problems to try. The pop-up in the video will come up shortly.